If f of x equals x over x minus 1, g of x equals the cube root of x, and h of x equals x plus 5, find f of g of h of x and g of h of f of x and their domains. So we'll start with f of g of h of x. That's going to be f of g of h of x in the middle. And we know we need to start from the inside out, so we've got to start by plugging in h of x. That's just x plus 5. So this is going to be f of g of x plus 5. Then we have to apply g to x plus 5. The function g just takes the cube root. So g of x plus 5 is going to be the cube root of x plus 5. And if we want to think ahead a little bit about what's going on with the domain, so far there's no real issues here because we can always add 5 to anything, and we can always take the cube root, whether it's positive or negative. So there's no issues so far. The only domain issues might come in when we apply f. Now, f of x is a rational function where the numerator is just the input and the denominator is the input minus 1. So if we're evaluating f at this cube root, that's going to leave us with the same cube root in the numerator. And then in the denominator, we're going to have to take that cube root and then subtract 1 from it. So we have our composition of functions right here, but we're also asked to find the domain. And we know that we need the denominator to not be equal to 0. So basically, the cube root of x plus 5 minus 1 cannot be 0. Now we can add 1 to both sides to get that cube root alone. And then to get rid of that cube root, we can cube both sides. X plus 5 is not equal to, well, 1 cubed is just 1. And then if we subtract 5 from both sides, that tells us x is not equal to negative 4. So our domain is the set of numbers x such that x does not equal negative 4. If x was negative 4, when we plug that in here, we'd have negative 4 plus 5, which is 1. And then the cube root of 1 is 1, and then 1 minus 1 is 0. That would give us a 0 in the denominator, so our function's undefined, so it can't be part of the domain. Now that was just the first half. We also are supposed to find g of h of f of x, which we can also write like this, g of h of f of x. And again, we're going to start working from the inside out. We need to plug in f of x inside that composition. And f of x is the rational function, x over x minus 1. So already we know that x can't be 1 because that would give us a 0 in the denominator, and we would be asked to evaluate h at something that's undefined. So already we know x can't be 1. But let's keep going. We now need to evaluate h at x over x minus 1. Now, h is the function that adds 5 to whatever we have. So this is going to be g of x over x minus 1 plus 5. And then we need to evaluate g at that input. G as a function just takes a cube root. And so this is going to be the cube root of x over x minus 1 plus 5. And we don't need to worry about any domain issues coming from the cube root because we can take the cube roots of positives or negatives. The only issue where we have to have concerns is a 0 in that denominator, which happens when x is 1. So that's the only problem for our domain, which means the domain is the set of numbers x such that x does not equal 1. And that's that.